Problem 7. Let n is equal to that quantity. What is the ratio of the sum of the odd divisors of n to the sum of the even divisors of n? So first of all, you do not want to be making this by hand. You want to do it some way that's much more efficient. And to do that, you want to be able to understand the definition of a number to be odd and even. If a number is odd, by definition, it does not contain a factor of 2. But a number that's even, by definition, has a factor of 2 to some power k times another number n. So given this definition, how are you supposed to frame this question? Well, you're trying to find divisors. And whenever a question gives you that they want to find divisors, it's probably your best bet that they want to have you prime factorize a number. So 34. 34 is 2 times 17, so then we have 234, so we have 2 squared times 17 squared. Okay, now let's do 63. 63 is 7 times 9, which is equal to 7 times 3 squared, so 7 and 3 squared. 270 is 27 times 10. 27 is 3 cubed times 2 times 5. So if we put it into here, then we add an extra 2 to become 2 to the third. 17 squared doesn't change. 7 doesn't change. 5 puts in here. 3 to the second times 2 to the third gives 3 to the fifth. So that's the prime factorization of n. So how are we supposed to find the sum of all odd divisors? Well, obviously, with this many prime factors and to as high of a degree as they are, you do not want to be doing it by hand. So there has to be a better way. So the way to do this in competitive mathematics is actually a very cool trick, which is that if I were to give you a sub-question, which is that find me all the possible combinations of 2 and 3. And by 2 and 3, I mean, all the possible numbers that can be made from 2 and 3. Multiply together, that is. So to do that, how are you supposed to do it? Well, that's simply 2 to the 0 plus 2 to the 1 times 3 to the 0 plus 3 to the 1. And if you factor it out, you will see why. This is 2 to the 0 times 3 to the 0 plus 2 to the 0 times 3 to the 1 plus 2 to the 1 times 3 to the 0 plus 2 to the 1 times 3 to the 1. So what is the interpretation of this? Well, 2 to the 0 times 3 to the 0 just stands for having 0 2's and 0 3's. That means we can result in 1 if I were to choose 2 and 3. I cannot choose 2, I cannot choose 3, and I get a result of 1. I cannot choose 0, but I can choose 1 3 to get 3. I can choose 1 2, but it's 0 3's, and I'll get 2. I can choose 1 2, and I can choose 1 3. That will be equal to 6. So you notice that one of the patterns involved here is that to find the combination of all possible sums of the two given divisors, you just simply find the probability of picking as many as there are. So for instance, if I have 3 2's, then that means I can have 0 2's, 1 2's, 2 2's, or 3 2's, and that's the probability that you're trying to solve for. So back to this n question, how are you supposed to frame it? Well, for n odd, what would it be? Well, from the given definition, 2 cannot be involved, so it can only have 17 to the 0, 17 to the 1, 17 to the 2, and then we can have 7 to the 0 plus 7 to the 1, and this goes on and on to 3 to the 0 plus on and on to 3 to the 5. Now, let's do n to the even, right? N to the even, by definition, can have a factor of 2. In fact, it must have a factor of 2, or else it won't be even. So we must have 2 to the 1. We cannot have 2 to the 0, because the interpretation of that is you do not choose any 2's. So this added with 2 to the second, added with 2 to the third, and then you multiply by 17 to the 0, 17 to the 1, 17 to the 2, and this goes on and on to 3 to the 0, plus on and on to 3 to the fifth. Notice that if we set n to the odd to be equal to y, then how can we rewrite n even in terms of y? Well, that's just simply this terms times y, right? So 2 to the 1 plus 2 to the 2, 2 plus 4 plus 2 to the third is 8, gives 12, 14y. So that means the sum of the evens is 14y, the sum of the odds is just y. So if we scroll back, we are trying to find the ratio of the odd to even, so that's y to over 14 over y. Factor out y, so 1 over 14 gives you answer choice C.